Hello good people, I'm going to explore some alternatives to molarity. In very general terms, concentration can be expressed as the mass of solute per volume of solution. Note that there are no set units. When we talk about molarity, our units are number of moles of solute and the volume has to be in liters. When it comes to concentration, the units can be whatever is given to us. If I dissolve 125 milligrams of sodium chloride in 235 milliliters of water, the concentration can be calculated by dividing these two numbers. And the units happen to be milligrams per milliliter, because those were the units that were given to me. In this particular case, 125 milligrams divided by 235 milliliters will give me 0.532 milligrams per milliliter when rounded to three significant figures. In a similar fashion, if I was to dissolve 3.16 grams of sodium hydroxide in 6.82 liters of water, my calculation would be 3.16 divided by 6.82, and that would give me 0.463 grams per liter when rounded to three significant figures. My units were dependent on what was given to me initially. Be aware that different disciplines have different ways of talking about concentration. In chemistry, in most cases, we use molarity. In nursing, concentration is often expressed as percent weight per volume. And the formula for percent weight per volume is exactly what it says. I will have the mass of the solute, note that it is in grams, divided by volume of solution in milliliters, and all of that multiplied by 100. Let's say I have a patient with a potassium deficiency, and I'm going to hook them up to a 0.02 liter solution in which 3 grams of potassium chloride have been dissolved. What is the concentration of this solution in terms of percent weight per volume? According to the formula, I'm going to take the 3 grams, divide it by 20 milliliters, and multiply it by 100. In this case, this gives me 15%. Or more precisely, it gives me 15% of potassium chloride solution. Keep in mind that for this calculation to work, the units need to be correct. The mass of solute must be in grams, and the volume of solution should be in milliliters. So percent weight volume is what we use when we dissolve a solid into a liquid, and in most cases that liquid is water. However, we can also dissolve a liquid into a liquid. In that case, our concentration is expressed as percent volume per volume, and the formula is rather similar. Now we have volume of solute in milliliters divided by volume of solution in milliliters as well, and once again we multiply the whole thing by 100. In case of methanol poisoning, an ethanol solution can be administered to help. And so I might have 0.006 liters of ethanol in a 60 milliliter solution. To calculate the concentration in terms of percent volume, I would need to dissolve the volume of ethanol by the volume of the solution. Note that for this calculation to work, I need to convert the 0.006 liters to 6 milliliters. 6 milliliters divided by 60 multiplied by 100 will give me 10% ethanol solution. These are not the only ways that we can talk about concentration. For example, in environmental science, concentration is often expressed in terms of parts per million and parts per billion. If we are talking about aqueous solutions, in other words, things dissolved in water, parts per million, or ppm, translates to mass of solute in milligrams divided by volume of solution in liters. And parts per billion, or ppb, translates to mass of solute in micrograms divided by volume of solution in liters. Suppose that I have 0.037 milligrams of arsenic in a 2500 milliliter solution. What is the concentration in terms of parts per million and parts per billion? For the parts per million calculation, I'm going to take the mass of arsenic in milligrams, 0.037, and divided by the volume of solution in liters. This means that the given volume of 2,500 milliliters needs to be converted to 2.5 liters. And once the calculation is done, I end up with 0.015 parts per million when rounded to two significant figures. The calculation for parts per billion is similar. This time I need to convert the milligrams into micrograms. And when everything is said and done, I end up with 15 parts per billion when rounded to two significant figures. Now this does not sound like much, but when it comes to arsenic, anything above 10 parts per billion is considered toxic. Please note that ppm and ppb are also often used to talk about composition of the atmosphere. However, when we talk about atmospheric composition, we have to be careful about our units. They are not the same as before. When we say 425 parts per million of carbon dioxide in the atmosphere, we are not saying that the mass of carbon dioxide in milligrams divided by volume of air in liters will give us this number. So this is incorrect. When we talk about atmospheric composition, we are actually talking about the number of molecules present. The 425 parts per million of carbon dioxide are calculated by using the number of carbon dioxide molecules in air, dividing it by the total number of molecules in air, and multiplying the whole thing by 1,000,000. So, when we talk about atmospheric concentrations, rather than using milligrams per liter, we actually tend to look at numbers of molecules. Alright, I can feel your concentration slipping away. That is all for now, and I will see you on the flip side.